at the start of my year 2 in the school, or a year 2 in the college, or in the university, I had to write codes to read from the socket and write to the socket. I mean, what people see over the network. And that is lots of coding. RMI, JNDI, and other packages now, they are offering you packages on the top of the sockets to make sure the communication is done easy for you. We will be talking about remote reference layer. This graph is only for, let's say, making it easier for you to understand the architecture of the RMI. It is as a result of running a system. This graph at this moment is for distributed process, distributed programming, centralized process. That's the central server, and that is one client is talking to that server. Okay. At this moment, let's just think about the server. The server will have a Java implementation, and this is saying there is something, this is a class called skeleton. This is generated by the RMI architecture. That's an underlying class sitting there, created, and code embedded inside automatically using the RMI, let's say the RMI compiler, which we don't need to use. It will be done automatically by Java now. And that will be responsible on the communication with this stub. This stub is here at this moment because that client looked up that implementation over the network. But practically, this stub is the interface to the skeleton. It will talk to the skeleton. These two classes will talk to each other over the network. These two classes, the stub and the skeleton, they are usually here. They are under the server side. So the stub and the skeleton, these two extra classes, they are created on the server. But the stub is then transferred to the client when the client look up the service here. Okay. The nice thing, what we will need to understand at this moment, the availability of the stub and the skeleton, practically at this moment the stub is a class will be transferred to the client when you look up that specific application, which is an RMI configured, which allow that client to call methods like the JNDI, but a bit slightly different, to allow that client to call method locally. Okay, they look like they are locally on the client. After down referencing them, not downcasting, down referencing these classes, which is, this is an example of it. But then the execution will happen here. And that is the big difference between RMI and JNDI. In JNDI, what we've done, we downcasted. We downloaded the copy of the object. We've got a hold of the whole copy locally. And we've used its methods, right? Did we use the methods locally? Yes. When we downloaded that reference to that file system, we've been calling that class like if it's locally sitting. Yes, it was locally sitting. But we downcasted it. We looked it up, we got a copy, and we started talking to it. These two extra, stub and skeleton, plus the underlying development, including remote reference layer and transport layer, will allow you to get only a reference. And it will look like you've got the copy of the object locally, but actually you don't. You are only talking to a reference, and the execution will happen here. I'll talk about it further. So simply, if we're going to go bottom up, the transport layer will allow me to talk over the network. So you don't need to write code for that. There is another layer called remote reference layer. That remote reference layer is simply responsible for managing things we call them remote objects, etc., which you don't be bothered about. These are created, and you just inherit them, and they will manage the communication for you. Okay, so they will manage this one-way or two-way communication. You just inherit the functionality. We'll look at how we can inherit these functionalities. And they allow us to talk to the stub and the skeleton. I mean, if I go back, There is some implementation here, things related to remote functionality. I mean, it might be a good idea to talk about one word at this moment. This is centralized process. It allows clients to talk to it remotely. So the word remote is coming from that concept. So you people are going to call these methods from a different site. So remotely they're going to talk to it. So they need some remote implementation which manage the communication. If you remember some time ago when we talked about the observer, the best way was to implement that people watching a certain object and they won't be notified is not direct coupling between the two, right? That's, if we do it this way, that's a direct coupling, won't work. We need to link lots of things at this side. The better way was indirect coupling. So the better way then, when they build upon that design pattern is, okay, if we can implement something, let's just implement the low level and connect to the low level and let indirect coupling works, which is how we're going to do it. So the remote reference layer is there, which will allow you to the management of these remote objects. Obviously, we don't create these, we just inherit these. Okay, the stub is the interface for the client, simply what we need to understand at this moment. The stub is going to be created here on the server, but it's the interface for the client. The skeleton is going to be created on the server, but it's the interface for the server. So these two will talk to each other through the remote reference layer, transport layer, which you don't need to be bothered about. Okay? We'll look at how we can do it. So what we've got in terms of the packages. We've got remote. It's a base interface for the functionality of the remote object. So it will allow you to send and receive things through the network. It is remote object for all remote objects. There is remote server for the server side. There is unicast remote object. It's a class which it's the code for the TCP/IP code, socket programming, communication, maintaining the links, and talking and sending and receiving messages over the network, and listening to the socket, etc. This is all inside unicast remote object, which we don't need to be bothered about. What you need to know at this moment, if we look up a reference, an object, and we down reference a copy or a reference to that specific remote object from the server, we just need to call a method inside it, and the execution will happen for us in the server. And that's it, nothing more than that. And there is exceptions, and there is two libraries, RMI.star and server.star. So if we're going to create such an application, what do we need to do? First, we declare a remote interface. Then implement that interface. Then create the stub and the skeleton. At this moment, we don't do that anymore. That is done by the JDK, because we are using JDK 1.8. That's less than 5, then you need to do that. Okay? Export, create the publishing application. Oh yes, we need to start the RMI registry, because where we gonna share these remote services, we need to publish them somewhere. Our application server at this moment is something called the RMI registry. Yes, you run something in the command line, it will run there like Tomcat, but it's an application server now in which you can share these services over, and we will see that easily. Run the publishing program, create a client, test and debug. That's a bit fast because I tend to talk more here rather than on the list, on the code I mean. That's a bit easier now. At this moment, I am sitting here developing the server side. The server side. If I'm going to create an application, distributed programming, centralize the process, simply I am configuring only the server to allow for methods to be called remotely. Okay? Methods to be called remotely in an easier way. Simply, if I am the server, I will need to say these 5 methods, you can call them from the USA, wherever, over the network. You look up this class, You get a reference to it and you can call these methods. That's a nice thing. If they got a reference to a class, you can tell which methods they can call. Not everything. You can call which methods. Okay. So first of all, if I'm going to do that for a certain number of methods, I will need to put these method signatures in an interface. Public interface, I'm calling this, I'm making one method to be called remotely only. I'm going with the simplest example. I want to create a server, and that server will allow for one method to be called remotely from another computer over the network, and the execution will happen on the server. First, I'll need to create an interface. I called it a speech, and that speech extends remote. Interesting. I don't want to go to further details. That's an interface. But notice this. I'm extending an interface. Some people might say, oh, what's that? Yes, sometimes in programming, even if it's an interface, we extend an interface rather than implement an interface. Don't want to go there, but obviously because that interface is extending something else, which is the unicast remote object, then it's very important to extend it in this case. It's an exceptional case. And I'm putting